Eric Burgess here, and we've been asked to solve the following set of triangles. So in this particular case, we see that we have a 45-45 triangle, right? Because if this is 45 degrees and this is 90 degrees, they have to add to 180. That means that this last one has to be 45. Then this one has to be a 30, 60, 90 triangle. Another important one. So let's just recall the properties of these triangles really quickly. So for the 30, 60, 90 triangle, if we were to do one real quick, we have a 30, a 60, and a 90. Well, the side opposite it is going to be, right, if we were to pick the most basic case, well then across the 30 is a 1, across from the 60 is a radical 2, and across, or my bad, a radical 3, and then across from the right angle is a 2. So this would be the property that we have here. But ours looks a bit different. Instead of it being rad 3, we have a 7 here. And so let me in fact do that in a different color. So we've got a 7 here. So if these are all proportional, then I could say that, okay, well, let's just pretend that if we say, well, okay, this has to equal 7, and we know that this side, right, I could multiply all of these by a, and it would remain true. So for example, if I multiplied everything by, I don't know, let's test it. Let's do 3. So we would have 3 squared plus 3 rad 3 squared equals 6, right? Because 2 times 3 is 6 squared. And if we were to do this, we would get 9 plus 3 rad 3, which is 9 times 3, which is going to be, what is that, 27? And then 36, we're going to get 27 plus 9, which is going to give us 36. So what we want to do is use this ability to figure out what this thing should be here. So this rad 3 was scaled by some factor a to give us 7. So we have rad 3a 7. And if we can figure out what a is, we can do the other two sides. So if we do this, we say, okay, well, this is going to be a equals 7 divided by rad 3. And so knowing this, we can say, well, if this is what this side is, it's simply just whatever a is. Whatever a is going to be whatever this bottom is. So m is just going to be this. So we've already got m. M must equal, and let's rationalize it to 7 rad 3 over 3. So now that we know m, we can go ahead and figure out a. Now a is just 2 times whatever a is. So a is going to equal, and I'm going to write it over here, a is equal to 2 times this. So that's going to be 14 rad 3 over 3. That's what a is. And so we've already solved one of the triangles. Now for the other triangle, we could do a similar thing. So for a 45-45-90 triangle, if I were to draw one like so, just pretend it's 45-45. I know it's not, doesn't look like it, but we're going to define it to be one, okay? So with this one, the way this one works is this is 1, 1, and this is radical 2. And because if we have 1 squared plus 1 squared equals rad 2 squared, which is going to end up being true. So knowing this side, again, if we apply the a, well, we already know this has to be the same as this. So again, this is not only a, this is also equal to n, because this side has to be the same because they're 45-45. And the sides, when the angles match, are going to be equal. So to find q, all we got to do is use the same thing down here. So we have rad 2 times whatever a is. So a is this mess over here, so we're just going to multiply that by rad 2. So it's going to be rad 2 times 14 rad 3 over 3. We can multiply and we get 14 rad 6 over 3. and this is going to equal Q. So we have A, we have N, we have Q, and we have M, which I put down here. And that is all you got to do to solve this triangle. So it's just a combination of special triangles. So if you know your special triangles really well, these problems should be pretty straightforward. Fortunately, we didn't have to pull out any definitions of sine or cosine or anything. We were able to do it all just using straight up special triangles. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.